And we are back, and today we're going to talk about structural descriptors of bonding. So we've talked a little bit about different types of bonding, distinguishing between different types of intramolecular bonding based on electronegativity. We know how the electrons shared, gained, et cetera, et cetera. We know that covalent is directional, ionic is non-directional, but we haven't really, we could kind of specify more into the structural descriptors of bonding. So we've talked a little bit about bond length. So when we have our sp3 hybridized bonds here. So this is tetrahedral, so the angle is 109.5 degrees, tetrahedral angle. But we've talked about the bond length here being 1.54 angstroms for a carbon-carbon, or actually carbon-carbon saturated bond. But anyways, but we could describe bond length, bond angles, and the size of atoms or ions. So bond length is just going to be the distance between the two bonds, so that 1.54 angstrom. Bond angles by the relative location of the atom. So if we have a bond CO2, for example, this bond angle here is going to be 100 degrees. If I have BF3, excuse me, not 3, this angle here is going to be 120 degrees. And again, you can see the angle for our 109.5 tetrahedral. You could also kind of describe the size of an atom too, again, the electron distribution. But the key thing is once you know what type of bonding is occurring and you're trying to describe the size, we want to pick either the covalent, ionic, metallic, or van der Waals radii of the atom. So for metals, you're going to use metallic radii. If they're covalently bonded, covalent radii. If they're ionic radii. So that's and van der Waals radii. So we're going to kind of use that approach. And actually, there's a really cool kind of subsection of material science where you can predict basically the shapes and bond angles and bond lengths using this electron domain theory, and actually really the bond angles. So you can kind of deduce this structure, and it actually distinguishes between bonding and non-bonding domains. So you can figure out and actually predict these kind of preferred bond angles. So for 2, this electron domain theory, EDT, theory will predict 180 degrees apart, for 3, 120, and for 4, 109.5. So that's just a little bit more into the structural descriptors of bonding. And next time we're going to get into isomerics. I'll see you all in the next video. Thanks.